recording. All right. Dilations and similarity in the coordinate plane. So we got to figure out what dilations are. So this is our last lesson of the chapter. We know what similarity is, right? Similarity means the same shape, right? But not necessarily the same what? Yeah, different sizes, but the same shape. So what is a dilation? Well, a dilation is a transformation that changes the size of a figure, but not its shape. So go ahead in that first blank and write dilation. So a dilation is a transformation that changes the size of a figure, but not its shape. So go ahead and write dilation. Okay, so dilation, remember we started learning about dilations, right? The pupil is getting bigger or smaller, right? So we're changing the size, but not its shape. And a what describes how much the figure is enlarged or reduced? A scale factor. So a scale factor describes how much the figure is enlarged or reduced. So if, for instance, I dilate the shape and it's doubled in size, then the scale factor is 2. If it's tripled in size, the scale factor is 3. If I cut it in half, so it's half the size, then the scale factor is 1/2, or 0.5. Does that make sense to you guys? Question?
No, it's all right.
So a dilation changes the size, but not its shape. And a scale factor tells us how much bigger or smaller it got. Okay? Is that pretty clear? All right. So next, let's go into an example of a dilation. Okay, so here we see that we have our original triangle, it's a small little triangle there, and then it's dilated to make it bigger. All right, so take a look at that. We see the original triangle there in the small little red triangle, and then it dilates to make this bigger blue triangle that I'm going to highlight and do here. So first off, are these triangles the same shape? Yes or no? Yeah, they're the same shape. Are they the same size? No. So what has occurred? It begins with a D. It's a dilation. Very good. So dilation has occurred. So the question is, find the coordinates of D and the scale factor. Well, how do we find the scale factor? Well, we take a look here and we see that we're given this coordinate is 4 and that coordinate is 2. So to find the scale factor, you just divide. You do 4 divided by 2. And you always do the dilated shape over the original. Okay, the dilated over the original is 4 over 2. What's 4 divided by 2? 2. Okay, so our scale factor is 2, so that's done. All right, scale factor is 2, so that's done. Now, let's take a look at this. If this point is at 3, how do I figure out where D is at? Do I divide by 2? No, I multiply. I multiply by the scale factor. So this starts at 3. Where's D going to be? Well, it's going to be at 3 times 2, which is 6. So 6. And it would also be 0 times 2. But what's 0 times 2? 0. So it's still at 6, 0. Does that make sense? Is that pretty clear to you guys? So how do I find the scale factor? I use the points that I know. 4 and 2. So 4 divided by 2 is 2. And then I multiply to get the next point. Is that pretty clear? All right. So now we have an example that you guys are going to do on your own. The check it out example there.
Wait, so after we finish this example, we're going to do the oops.
After we finish this example, I'm gonna go. Actually, I probably should have done the other part of the lesson first, but it's okay. I'm gonna go back and finish off lesson 7.5 because lesson 7.5 is we didn't finish it. We had one more point, and then we're gonna Kahoot. What?
I guess 7.5 on worksheet.
Yeah. Mm-hmm.
That was in here.
Yeah. So shh. Okay. So let's. What was that?
This is squiggly, you mean similar?
Similar. Yep. So let's take a look, Priscilla. P is negative 15, 0. So mark that there. M is negative 10, 0. So that's negative 10, 0. Q is 0, negative 30. And it's finding N. They want you to find N. Okay? So our original shape this time is the big red one, right? Because, look, we don't have N. So we've got to find that. Does that make sense? We don't have N, so this is the dilated shape. Usually it tells you, it should tell you that this is the dilated shape, okay? Usually it will, so I'm telling you, this is the dilated shape. Okay, because that's the one we're trying to find. So how do I find the scale factor? How do I find the scale factor?
Divide 15 by 10. Cross multiply.
Now, here's what I need to do. I've got to set up my ratios just like I usually set up my other ratios. Okay? So, I look and I say, okay, well, MO, that's this one, over PO, God bless you, equals NO over QO. So this side MO divided by this side is equal to this side NO divided by QO. Does that make sense? You guys remember this? We're setting up our ratios. So I got to figure it out. Well, MO is how much? It's 10, right? Negative 10. So it's negative 10 over PO, which is, yes, sir?
Should we put the original on the bottom? Negative 15. Use it dilated over bottom.
Yeah. Okay. So this is one way to do it. Let me just continue this way, and then I'll show you the original way that I showed you. Okay? So it's 10 over 15 equals NO, we don't know, right? Over QO.
Oh, I didn't even realize that NO, we don't know.
Yeah, nice. QO is what? What's QO? Negative 30, right? So what do? I could cross multiply, but I just have to multiply both sides by negative 30. And I end up with NO equals negative 30 times 10 is 300 divided by negative 15 equals negative 20. So there's my point, 0, negative 20. Okay? Does that make sense to you guys? I set up the ratios the same way. Now, what's the other way to do it that honestly is the more simple way? Okay? I could set up my ratios, but instead of that, what I suggest that you guys do in these instances is just do dilated over original to get the scale factor, and then you just multiply. So the dilated shape is which one? Negative 10 or negative 15? Which one is the dilated, the blue or the red?
Blue.
The blue. So what's the blue? Negative 10, you see? This is the dilated triangle, so it's negative 10.
How do you know it's a dilator?
Because it will tell you. Okay? It will tell you, or it'll be like, for instance, this, now let me be honest. This is very unclear, this question. It should tell you specifically that this triangle is dilated. Because otherwise you can't get the scale factor. Does that make sense?
Wait, what does this wiggly line mean?
Similar. Alright? So, it's negative 10 over the bigger one, which is negative 15, right? So you take the smaller over the bigger. And what is that? Well, that simplifies to 2/3. Okay? That's the simplest form of that fraction.
You divided by what?
Divide by negative 5. I divide by negative 5 on the top and negative 5 on the bottom. So the scale factor is 2/3, so that answers that question. And then how do I get n now? What do I do? What do I do with the scale factor? I multiply. So I take negative 30 and I multiply it by 2/3. Right? Negative 30 times 2 is negative 60. Divided by 3 is negative 20. Is that pretty clear? Okay, so you find the scale factor by doing the dilated over the original, negative 10 over negative 15. That gives you my scale factor. You see? Then to get my new point, my final point, all I do is multiply by the scale factor. I multiply the point by the scale factor. Is that pretty clear? Okay. All right, now we've got to finish off lesson 7.5. Who wasn't here yesterday?
It was
You just Friday?
Yeah.
You mean not Friday.
Whatever it was.
Tuesday.
Tuesday, yeah. You were, right? Okay. So, yeah, you were. Who else wasn't here? Anybody else not here Tuesday? Okay. Everyone should take out your packet, 7.5. You should have your 7.5 packet. If you were here, you should have it. I hope you guys are keeping good track of these. I have one extra if someone needs one.
Wait, the pineapple?
Yeah, the pineapple. And then when you get to your packet, go ahead and turn to the very back page. This last page here. Okay. And that's what we're going to go over, and that will be the end of our lesson.
I don't think I have it. Oh, yes, I do. It was here. It's in my notebook. Oh, never mind. I was the wrong one.
Okay. I have one more extra if anyone needs one. You need one, Akira? You good? You have one? No?
Oh, I thought you didn't get it. Oh, I just didn't have it. You don't have it? No. So, well, I'm ready. And then wait. There you go.
All right, just look at Colton's or work with Colton, okay? All right. All right, so let's everybody turn to so the back page, lesson 7.5. And we get similarity, perimeter, and area ratios. Okay. So everyone take a look at this. Go ahead and take a look at this yourself and see if you can figure out what it's showing you. Similarity, perimeter, and area ratios. Focus, Marcus. Focus your mind. I'm not giving this time just to waste it. I'm gonna use it. All right. So, what do we see here? Well, we figure out that here's the similarity ratio between the two, right? Okay, AB over DE is 5 over 10, which is 1/2. So this is half as big as that. Well, let's find the perimeters of both of those shapes and see if we can figure something out. Well, the perimeter of this one is 5 plus 4 plus 3, which is 5 plus 4 is 9 plus 3 is 12. Okay? So this is 5 plus 4 is 9 plus 3 is 12. So that's the perimeter of that shape. What's the perimeter of this shape? Well, it's 10 plus 8 is 18 plus 6 is 24. Well, if we compare the perimeters, we'd get 12 over 24. But how do we simplify that? What's the simplifying factor here for this fraction? 12, right? So we get 1 over 2. Well, hey, look at that. So the similarity ratio is the same thing as the perimeter ratio. So if I tell you, for instance, I didn't give you these numbers, but I told you that the perimeter of this is 20, what do you think the perimeter of this would be? 40, right? Does that make sense? Or, for instance, if I gave you that the perimeter of this is 60, what would this perimeter be? 30. Why? Because the perimeter ratio is 1/2. Does that make sense to you guys? Is that clear? So the perimeter ratio is the same thing as the similarity ratio. If this side is half of that side, then the perimeter of this is half of the perimeter of this. Does that make sense? So all I have to give you is the perimeter of one shape, and you can figure out the perimeter of the other as long as you have the similarity ratio. Does that make sense to you guys? Okay. But let's take a look at the area. The area of a triangle is what? 1/2 base times height, right? So here the base is 3 times 4. 3 times 4 is what, class? 12. What's half of 12? 6. Okay, so the area of that is 6. And the area of this is 1/2. 6 is the base times 8. What's 6 times 8, class? 6 times 8. 6 and 8 is 48. 6 and 8 is 48. 6 times 8 is 48. What's 1/2 of 48? 24. Good. All right, so let's take the ratio of the areas now. We do 6 over 24, and we get 6 over 24. What's the simplifying factor? 6. 6 divided by 6 is 1. 24 divided by 4 is 4. Wait a second, that's completely different. Instead of 1/2, the area ratio is 1/4. Well, how do I get that? Well, I square it. I take my similarity ratio and I square it. Okay, why do I square it? Well, because you're multiplying the similarity ratio by itself. You see, when you're doing area, you're not just adding, you're multiplying. And when you're multiplying, you get like a square. So an area, for instance, if I say to you something like a room is 10 feet by 20 feet, well, the length and the width is 20 feet long by 10 feet long, right? But if I ask you for the area, you wouldn't say it's, 200 feet. No, it would be 200 what feet? 200 feet squared, or square feet, right? So our area ratio, because it's squared, right, like square feet, you're squaring the similarity ratio. Does that make sense? Yeah? Okay, so if I told you that the area of this one was 40, what would the area of this one be?
20.
What?
120 squared.
10.
10 squared.
Because the area ratio is 1/4. Does that make sense? So the area ratio is the square of the similarity ratio. What does this mean?
Why would it be 10 squared?
it wouldn't be 10 squared. Let me show you. If the similarity ratio is equal to 4, let's say, what's the area ratio? 16. Why? Because 4 squared equals 16. If the similarity ratio is 3, what's the area ratio? 9. Why? Because 3 squared is equal to 9. If the similarity ratio is equal to 10, what's the area ratio? 100. Why? Because 10 squared is 100. The area ratio is the square of the similarity ratio. Does that make sense? Okay. So, what about if the similarity ratio is 1/3? Well, the area ratio is 1/3 squared. And I square the top and square the bottom. 1 squared is 1, and 3 squared is 9. So the area ratio is 1/9.
So if we find the perimeter first, we don't even have to we can just square the perimeter.
No,
Why not?
because the perimeter squared is not the area. Do you mean the perimeter ratio?
Yeah, the ratio.
Yeah.
So if we just square or not,
You're given the similarity ratio. You'll see. You're given a similarity ratio, and then you have to square that to get the area ratio. And then you have to use that area ratio to find the area. So in this case, our area ratio is 1/4, right? So if I told you the area of this one is 40, then what would the area of this one be? 10. Why? Because 10 is 1/4 of 40. Does that make sense? Okay. Let's do an example. Let's do an example. Okay. So we're given these two triangles, right? So we see that this is 16 and this is 20, right? So this is our dilated shape, okay? Or not necessarily dilated. We want to find our similarity ratio of this one to this one, right? Okay. So how do we do it? Well, we take, and this is why it's a little bit weird that they do it this way. It's just completely silly to do it this way. I find the ratio of this one to this one, right? So kind of go off to the side here because I don't want to do it the way that they did it because it's confusing. All right? So
same for the example. Check it out.
well, I mean the way that they solve it is what I'm saying is a little confusing. Okay, so say you're given two triangles like this, all right? And I want to find the perimeter of this one and the area of this one on the right. You see? Are you guys paying attention? I want to find the perimeter and the area of this. Okay, I'm given the perimeter and the area of this one, and I'm given the side length here and the side length here. Well, if I'm given these two sides, what can I figure out?
Ratio.
The similarity ratio. So I start by doing the similarity ratio, and I get that it's 20 over 16. And I'll simplify that. The simplifying factor here is 4, so that becomes 5 over 4. You see? So the similarity ratio is 5 over 4. Well, if I want to find the perimeter, I don't use the similarity ratio, I use the perimeter ratio. But what do I know? The perimeter ratio and the similarity ratio are the same. The perimeter ratio and the similarity ratio are the same. So to find this perimeter, I just take 36 and I multiply it by 5/4. Does that make sense to you guys?
You just multiply the perimeter with
Yeah.
the measurement is.
The 36 feet is the perimeter of this one. So to find the perimeter of this one, I know that the perimeter ratio equals the similarity ratio, which is 5/4, right? So I just multiply by the perimeter ratio. Okay. What's the perimeter ratio? The perimeter ratio is the ratio of this perimeter to this perimeter. that make sense? So if I want to find this perimeter, I have to use the perimeter ratio. I just multiply them. That's it. 5/4 times 36. So I do 5 times 36, and that gives me 180. And then I divide that by 4, and I get 45. So the perimeter equals 45 feet. Okay? That makes sense? So I found the similarity ratio. I know that the perimeter ratio is the same as the similarity ratio, and so I just multiply this perimeter to get the bigger perimeter. Does that make sense to you guys? Any questions on that? Okay. Now, with the area, I can't just use that ratio, right? I have to find the area ratio. But what did I say the area ratio was? The square of the regular of the similarity ratio. The square of the similarity ratio. Okay? So it's 5/4 squared is the area ratio. So I square the top and I square the bottom. What's 5 squared, class? 25. Good. And what's 4 squared? 16. Okay. And then I don't have actually, there's no simplifying factor here. There's no simplifying factor, so this is my area ratio. Now, Priscilla, what do I do to get the new area? I have my area ratio. What do I do to get my new area? Divide. Multiply. I multiply this area by the area ratio to get the new area.
You multiply the what?
I multiply the original area, which is 48, and I multiply that by 25/16 to get the new area. Okay? Now, I could multiply these first, 48 times 25, but that's going to be really big. So instead, I'm going to divide first. So I do 48 divided by 16. Okay? 48 divided by 16 is 3. So this becomes 3 times 25, which is 75. So what's my new area? 75 square feet. Okay? $75 square feet. Okay. Any questions on this at all? So look, guys, this isn't that hard. We just have to be engaged with it. What am I doing here? I find my similarity ratio. How do I do that? Divide this by that. Okay?
Is it always big over small?
Not always. You just have to figure out which is the shape you're trying to find, right? If this shape was smaller, then I would do smaller over bigger, right? So the similarity ratio is the one I'm trying to find over the one I have. Okay? So it's 20/16 gives me the similarity ratio. Once I have the similarity ratio, I also have the perimeter ratio because they're the same. So I take this perimeter ratio and multiply it by the old perimeter to get the new perimeter. Does that make sense? Yes, that makes sense. I'm so happy.
Yes, absolutely.
Great. Okay. So then, to find the area ratio, I can't just use the same ratio. I have to square it because the area ratio is the similarity ratio squared. So I square it, I get 25/16, and then I multiply that area ratio by the old area to get the new area. So I do 48 times 25/16, I get 75.
So that's the area of that triangle.
That's the area of the new triangle. Yeah. The
So
new triangle.
48 is the area of the.
Yes.
Right?
Exactly. Okay. All right. So,
Can we do the examples together?
yes.
How does example do?
So the example is right here on the bottom. It says check it out. So here we have triangle ABC, and you should totally just draw the triangles rather than just keeping it in your mind. ABC and DEF.
get water or something?
Not right now, because we're almost done. Just pay attention. You can do it, Marcus. All right. It says BC is 4 and EF is 12. It says for triangle DEF, the perimeter is 42 millimeters and the area is 96 millimeters squared. Okay. Find the perimeter and area of ABC. You see how these pictures help? If you're taking a test and you're not drawing these pictures, good luck. I don't think you're going to do as well as if you draw. So draw the pictures. Draw the pictures. Draw it out. Don't try and just figure this all out in your mind. Draw the pictures. Now it's pretty simple. Now it's like, oh wait, this is the triangle I'm trying to find for. Okay, so how do I do it? Well, I do this. I have to find my similarity ratio. I do the one I'm trying to find over the one I know, right? So it'll be 4 over 12 to get my similarity ratio. Simplifying factor there is 4, so it's 1 over 3. Okay, that's my similarity ratio. So if I have my similarity ratio, what's my similarity ratio is 1/3. What's my perimeter ratio? What do I know about the similarity ratio and the perimeter ratio? They're the same. So if the similarity ratio is 1/3. My perimeter ratio is 1/3. Okay.
Wait, so you don't have to times 1/3 by 42?
No, that's to find the perimeter. The perimeter ratio is 1/3. Okay.
Oh.
Now to find the perimeter, what do? To find the perimeter, I do 42 times the perimeter ratio, which is 1/3. Does that make sense?
Yeah.
So 42 divided by 3 is 14. So there you go.
It's times 1.
42 times 1/3 is 42 times 1 is 42. Divided by 3 is 14. All right, now I got my perimeter ratio. Now I have to find my area ratio. What's my area ratio? What do? Is the area ratio the same as the similarity ratio, Matthews? No. How do I find the area ratio? No. I find the area ratio by squaring the similarity ratio. I find the area ratio by squaring the similarity ratio. So I do 1/3 squared. 1 times 1. 1 squared is just 1. 2, 3 squared is 9. So it's 1/9. Okay? So how do I find my new area? Well, I take my old area, which is 96, and I multiply it by my area ratio, which is 1/9. And I get 96 over 9. Okay?
And that's the area?
And you could turn this into a mixed number. It would end up being 10 and 6/9, which is equal to 10 and 2/3. So what is it? 10 and 2/3 millimeters squared is my area. How do I do this? Okay, I find my similarity ratio by taking what I want to know by what I have. Okay, divide what I'm trying to get by what I have, so it's 4 over 12. I get my similarity ratio is 1/3, which is the same as my perimeter ratio. So to get my new perimeter I just multiply my old perimeter by 1/3, and I get 14. Then to get my area ratio, I square the similarity ratio, and I get 1/9. So to find my new area, I just multiply my old area by 1/9, and I get 96 over 9, or 10 and 2/3.
How did you get 10 and 6 over 9?
Because 96 divided by 9 is 10 remainder 6. So 10 remainder 6 would be 10 and 6 over 9. This is how you turn an improper fraction into a mixed number. 96 divided by 9 is 10, remainder 6. You take the remainder and put it over the denominator. So it's 10, 6 ninths equals, simplify 6 ninths becomes 2/3. Okay, any questions on that? All right, so we are going to do our Kahoots now. So everyone take out your devices. What was that? Sure, go ahead.
Can you open up the 7.1 or 2, please?
7.1 and 2.
Yeah, I think there's one. I don't think we did 7.2.
Okay. Yeah, we didn't do 7.2.
Yeah, I think 7.1.
Okay, so here we go. Yeah, I will.
Is there a way to leave it open for until tonight?
Yeah.
So I can do it at home?
All right, here we go. Everybody? No, wait one person. No, but there's 11 people in this room right now. Who are we waiting on? No, there are 11 people in this room right now. Who's not in? Anybody? Reese plus 2 equals 9. Very good, Reese. Reese is equal to 7. These two rectangles are similar. Find the perimeter of RSTU. Okay, so here you go. So you're given the two sides. You have to find the similarity ratio.
So is what's needed on top?
Yep. What's needed is always on top. What you're looking for is always on top in these kind of cases. That's how you get your similarity ratio. At this point, you should have gotten that the similarity ratio is equal to 6 over 4, which simplifies to 3 halves. So, if the similarity ratio is 3 halves, then I just use that to find the perimeter ratio, which is the same. So the perimeter ratio is also 3 halves. And if I know the perimeter ratio is 3 halves, I get my new perimeter by doing 14 times 3 halves. Yeah, because this is the same thing as saying 14 over 1 is 3 over 2.
Oh, I got it wrong.
So 14 times 3 is 42 over 2. 42 divided by 2 is 21. Nice, Karen. All right. Now you find the area. It's the same problem, so you already have the perimeter ratio. You already have the similarity ratio. It's 3 halves. It's the same problem, but now you're trying to find the area. Okay? So you know that the similarity ratio is 3 halves. So you have to find the area. that?
Always use the
When you're multiplying.
We have 2 questions on
So, yeah. But you have to do the daily quiz from yesterday, though, too, which has 5 questions. So you should have now already gotten to the point that the area ratio is the similarity ratio squared. So 3 squared is 9, 2 squared is 4. So the area ratio is 9 over 4. And then to get the new area, you take the old area, which is 12, and you multiply it by 9 over 4. 12 times, which is your area ratio. 12 times 9 is 108, divided by 4 is 27. That's that one. 27. All right, now we're going back to the original part of our lesson. So find the scale factor and then the location of point C. Okay. Find the scale factor. Well, if I'm trying to get this one, the scale factor is 15 over 6. Okay. The simplifying factor there is 3. So it's 5 over 2, which is 2.5. So the scale factor is 2.5.
Okay, so the scale factor you just divide.
You just divide whichever one is being dilated divided by the original. So it's 15 over 6. It's just 2.5. Right?
And you just divide it. Let's just divide.
Take out the least common factor. Or the greatest common factor. To get the simplest. Okay? Shh. Mark, I want you to look at that. Just walk back into my class and make sure we're talking to those people while I'm trying to get focus. So 2.5 is the scale factor. To get point C, how do I get point C? How do I get point C if I've already got my scale factor? Well, I take point A and I multiply by 2.5 and I get 25. So where is this point? It's not at 0.25, it's at 25, 0. 25, 0, and the scale factor is 2.5. Alright, this one is exactly the same. This one is almost exactly the same. So see if you can do it.
This is the x-axis, or this is the y?
X is the horizontal. Y is the vertical. Okay, so let's look. I'm trying to get this one, the smaller one, so my scale factor is the smaller over the bigger, which is 4 over 10, which is 0.4. Okay? Or I could say it's 2 over 5, same thing. Right? So to get S, all I do is I take negative 20 and I multiply it by 0.4. What do I get? -8. Okay, so this point is at 0, -8. Does that make sense? So 0, -8, scale factor of 0.4. Nice. Okay, so you guys have a daily quiz to do today. It's only 2 questions, and the 2 questions are on things that we just went over. Just those last 2 questions on the Kahoot. So do that daily quiz. It's only 2 questions. You can get it done before lunch begins. We got like 4 minutes.
Bro, we haven't even been to lunch yet now that I think about it.
That's so true. Then it'll seem like a long day, right?
I thought it was Friday.
I thought this was like the last vlog.
I know.
Like we have one
I feel you guys. Look, trust me. I feel you. I feel you.
Are you serious?
Oh!
We haven't had lunch yet?
No,
I was wondering why I was so hungry. I was like,
trust me. I've been
Always
feeling it
hungry,
too.
I mean.
You know, I stopped drinking coffee like 2.5 weeks ago.
why would you do that?
It has been rough. It has been rough. I'll tell you. You guys think it's hard being a student?
Have you imagine,
Imagine
like, with
not
drawing?
drinking coffee and being a teacher and being the person that's up in front of you guys. Like, all right, let's do math.
I want to do that, then stay here every single class.
Same, because I feel like you could make it
Come on
like.
up.
I'd love to do that. You guys wouldn't learn anything. I'm telling you now.
That's the thing. Trust me.
You all
Last
would fail my
a
class.
couple years ago, I was up here being a ham, but people didn't learn that much. So I'm trying to get you guys to learn. So, but that's why I do things like the Kahoot and stuff to keep you guys engaged.
But if I
trust
were
me.
a teacher, I feel like I'd be like, okay, I was sitting here when I was younger. I know what it's like, so I would try to make it like easier and be like the test really easy and stuff like that.
Yeah, but the problem with that is that if I make the test
But like we don't
really
need math for our life, so.
Right.
Bro, yes.
That's true though.
Yes.
Well,
That's
Why
like an
are we
architect or
doing
a
this?
math major or something like.
So shame making it hard.
So
What am I gonna use this? Yeah, we're like, what are we gonna be like in our life? We're gonna be like, yeah, I remember the geometry to find the scale.
did you guys do your quiz yet? Did you do your quiz yet?
I'm doing it now.
Did you do your quiz?
I'm doing it now. Or I might do it later.
I'm gonna do it now, but I'm gonna sign in on his. Do I have time or should I just do it later? Because I have to sign in. Should-
Well, if you do it
Well, we have
now, then
lunch,
you don't bother potentially missing it and getting a 0 on it later. So,
I
so recommend you guys do it now. What do you have questions? Guys, let's be quiet, please. Let's get my seats.
I always feel like this box is usually $20.
Yeah.
Upside down. Put it in order like that. It can be fine and
It was, guys, we have people trying to take the quiz. If you're not going to take the quiz, fine, but let's be quiet.
If you want it, so.
Yeah.
So
I like it a lot. It's really cool, but yeah, that's why I bought it. It's really cool.
and then you can divide it by like 2.
I have a 61.
Should I sign
So
out?
I don't have like anything on the side of this. That's why I'm like.
Well, that's the x and the y coordinates. So x is the horizontal and y is the
Like
vertical.
this.
Yeah.
Oh, okay, so it'll be like -8 here.
Yes.
Like this one will be like the opposite 0.
Because it's vertical, you see?
So this could be like 24 over 12. Or 12 over 24.
12 over 24 because you're trying to find a small number. Does that make sense?
Mr. Mirror, I can't get out of Oh. So the one is the first one. I got it.
Wait, Marcus.
I mean, well, the thing is that we have a test on Tuesday, and so you're going to need to do those assignments to have the adequate practice.
Mr. Manier,
Yeah, the videos are all on YouTube, except for lesson 7.2. 7.1. So that is, yeah, exactly. So those should be able to help you. Alright, you're welcome.
I don't have this problem. Like, wrong. No, I put this one. But I thought it was 2.
No, because the scale factor, you were trying to find the smaller one.
But I divided it. It's
Right.
set 2.
But it was, so, as you can see, you divided it, but the point is that you were dividing the smaller by the bigger. Does that make sense? And so the smaller over the bigger means that the scale factor is 0.5.
Thank you. I'll try to finish the homework. I'll see one because since I'm doing FLPS and I'm trying to finish everything.
It's pretty tough.
Yeah, I'm about to end.
You're about to finish with FLVS?
Yes, but it's just like the last year. I have 4 modules, 3 modules left.
Oh,
So
wow.
it's a lot. That's the thing.
Yeah, I can understand that.
Yeah.
It's probably pretty tough to take 2 math classes at the same time.
Yeah, it kind of is. That's the thing. Then I'm trying to do your homework and then FOBS. No, when FOBS is done, it'll be easier now.
Yeah.
Which is good.
When do you think you'll be finished with that?
Before spring break, because my mom wants me to finish before spring break.
Oh, that's
So-
really good.
So I need to, so I don't think about it. Can I do it in here really quick so I don't have to do it after?
Sure. Yeah, that's fine. That's okay.
Because some of it probably
I mean, can you come into my office just so I can set you up in there? Because I don't know if Mr. McGuire is going to be in here. Do you want to come into my office and do it in there? Is that okay with you? Yeah, okay. It's just so weird. Because I noticed that sometimes, I'll try to open it up for you, but then it doesn't let me.
Do you want me to send you an email again?
No, it's okay. I don't know that I can even do anything about that. So I can
It's
try.
okay. I'll take it. 3 to 5 is not failing. So.
Well, okay. All right.
See you.
See you. Have a nice day. Hey,
How's it going?
it's going well. How are you doing?
How are you feeling?
Oh, it's a little rough.
Uh-oh.
Well, it's just the standards classes. It's just rough, and my integrated. It's starting to get to me. Last year, I had 2 honors classes and 3 integrated math.
It's quite different, right?
It's just the thing was at least last year I had those 2 honors classes
Oh, to kind of
where it's I could blast into you and be like, hey, what's up? And just go through it and have that kind of experience. But this year it's I've got 4 integrated math classes and then a standards class, and so it's just tough, especially in the standards is obviously my hardest. you know, but
That's why we like to say standards class is like Groundhog Day.
standards classes like Groundhog Day,
They don't remember anything.
that makes enough sense.
And they have to do the same thing over and over,
Yeah.
ask you the same question over and over. And I had them for a couple of years when I first got here. And it's
It's rough. But
really hard. I mean, thank goodness it's only one of them.
yeah, I think
I always found that you have to remember that God's going to work around their inability to do math, but you still have to present them with everything. Give a fair shot,
right.
but you can't dwindle in every single,
Yeah.
level.
You serious? Can I tell you something, Gary? This is the Gary, come here, mom, the same thing.
You know, you need to lay on our hands.
Yeah, I'm the party, Mrs.
Who ate it?
I got bread in my mouth and I
Yeah,
got
you should have eaten it before.
We could eat it before I was very busy yesterday.
You should have eaten it. You need to take your head up. You need to take your head up on the little books, the little things, and stop reading it. You talk about it again.